Hi, I like to make my own wireless lapel lavalier system. Like I said in my previous video, I think in my opinion it's the best way for quality audio recording because the microphone is closest to the source and picks up the voice as loud as possible, which reduces noise and echo. Also, you can walk far away from the camera.
It's as if I'm constantly whispering in your ears. Isn't that what you want? Wiggle, wiggle, wiggle.
A wireless lavalier has a transmitter that's clipped to my pants or whatever down there and a receiver that sits at the camera and plugs into the camera's audio input. But how do I make my wireless link? Maybe I link with two Bluetooth modules, or maybe two Wi-Fi modules so I can link multiple transmitters, or maybe I come up with my own mystery wireless link. Let me see if someone will sponsor a free sample. The good systems are usually expensive. There are a lot of companies out there that make this cheap though, but I don't want to be like,
wow, look at this product, so quality, much sound.
So I might as well aim high. For example, I know Rode Microphones makes pretty good products. Let's email them. Hello, love. In the meantime, I'm a lazy bum and like simple solutions. So here's my transmitter and receiver system. This is an FM transmitter which I picked up for around $20, and there are many models of this out there. What it does is that you plug it to your phone, for example, and it transmits your phone music to your car's FM stereo. It is useful if you're driving your granddad's car, which all it has is an FM radio. And this is my daughter's FM radio, which is my receiver. Let's try it out. On the FM transmitter, you have the option of selecting many different frequency bands, so you can pick one that's empty in your area for best audio quality. And then on your receiver, you tune to that frequency. Here we are. It has a bit of static noise, which is low, see? Let's play something on it.
We are the 3D printers.
The sound is not very good because the speaker is small. Also, I can see that the range could be an issue because both these things have short antennas. Still no response? Come on, man, I'm too cheap to buy a microphone. At mid-range FM frequency of about 100 MHz, the wavelength is around 3 meters. So a proper monopole antenna length is half that, or 1.5 meters, which is a bit too long. So a quarter wavelength of 75 centimeters or 2.5 feet sounds more adequate. In fact, instead of this garbage, I can use my cell phone's FM radio. The antenna is the headset cable, see?
And spruce steps, really wanted to add in there, and it gives it.
And I can make it as long as my proper antenna length. The app also shows me where the channels are, so I can pick a quiet band like this one and then tune the transmitter frequency to the same. See? And it's pretty quiet too. Now I just plug this into my camera audio input. Let's see what kind of range we get. Well, I walked pretty far, like 10 meters, before I ran out of space. Let's see if I can add some antenna length to this to make the range even longer. There we are. There we go. But now I kind of ruined the battery contacts. Where the hell is the antenna? Well, if I'm not wrong, like many of them do, they're using this cable as the antenna. So what we really needed to do was just to increase the length of this cable. It was kind of a waste of effort. Oh well, let's put it back together and hope it still works. Okay, let's check it before I completely close it. Lights up. There, I think it's okay.
Hi, high quality audio is very important
Good.
in video.
Oh well, let's get the audio going. I'm gonna connect my cheap microphone to the transmitter. And for that, I'm gonna solder two female audio jacks back to back. But I really think they should call the female ones Janet. That's it. From now on, this is an audio jack and that is an audio Janet. Okay, let's transmit. Hello? 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 This is a condenser microphone. Unlike the traditional dynamic microphones which have coil and magnet, this doesn't generate its own voltage. It's like a variable capacitor that changes by audio waves, so it needs to be powered and biased. So basically we put a resistor in series with the microphone between the supply rails, and the DC voltage here has to be set in the middle of the supply voltage for maximum signal output. And also that signal level has a direct relation to the supply voltage. Okay, I have the circuit on the breadboard. Let's power it up. I created a light bulb. Obviously there's a wrong connection. Come on, Rode, put me out of my misery. Okay, back in business. See? Hello? 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 It seems like around normal distance, the signal is not very large. It's around 100 millivolt peak to peak. Okay, I connected the microphone circuit through a capacitor to the FM transmitter and my phone is on the maximum volume. Let's hear it. Hello? 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 The volume is not too loud. Hello? 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 I think I need to add an amplifier to the circuit. This is the circuit I designed. Basically, the microphone signal goes through a buffer and then a gain stage that has a variable gain adjustable by this potentiometer. And the output goes through a capacitor to the right and left inputs of the FM transmitter, which also needs a ground connection. You can find more details on my website. I put the circuit on the breadboard. Let's do a quick smoke test. What's up with my circuits and all the smoke? A resistor makes a light bulb and a capacitor makes an explosion when connected wrong. No response. Okay, let's not give up. See, I fixed it. Hello, hello. Now the signal can be over 2 volt peak to peak. Num num. Birdie num num. And now, of course, the transmitter test. See? Echo. Hello. 1, 2, 3, 4. See? Awesome. Now all I need to do is to take all this circuit and put it on a prototype board. Life is a piece of shit. There we go. Input and output and volume control. This thing can run on 3 volts, which my FM transmitter already has. So I'm going to melt a hole into the body of the FM transmitter and run the power wires through it. Solder one of them to the battery negative and the other one after the power switch of the transmitter so it can turn on and off with the same switch. Now we just plug in the microphone and the FM transmitter and it's ready to go. Let's connect the phone to the camera. Okay, listen to the noise. And here's how I sound. Isn't it just a genius design? There is something called latency which I didn't consider. The sound itself takes around 3 milliseconds per meter to get to the microphone, and then a few more milliseconds to go through the electronics, get modulated, go to the receiver, demodulated, decoded, and go through the app to the output, and the whole thing together in my case takes 300 milliseconds. It's like talking across a football field. Yes! This video is sponsored by Rode Microphones, the builders of the best microphones in the universe! They are sending me a shotgun microphone and a wireless lavalier. I guess I'll check them in the next video. But it's such a shame. If it wasn't for the latency, this thing was decent. Now you might say you could align audio and video in post-process. Let's try it. Here I'm using my system and align the audio. I would say it sounds well. In fact, it makes sure that the right audio and video are always recorded together compared to recording audio separately. You just have to shift the audio in post-process. So it's not a total loss. The range you get with this thing is close to 10 meters, which is pretty decent for most applications. Something I learned aligning the audio and video was that our brain is used to delay to some extent. Like I said, it takes 3 milliseconds per meter for the sound to travel through air. So if you're talking to someone 5 meters away, it takes 15 milliseconds. Our brain has learned to expect delay based on distance. For example, right now audio is 60 milliseconds delayed from the video, but it doesn't sound too bad. And now the audio is 30 milliseconds earlier.